All right, folks, welcome back to data structures. We're doing some more stuff with our graphs. This topic is going to be transitive closure. Transitive closure is kind of a cool matrix multiplication trick that we can use to identify the existence of paths from one vertex to another. So we're going to start off by making an adjacency matrix. Here I have this little graph with 3 vertices and some edges. So let's get going here. 0, 1, and 2. 0, 1, and 2. Now, sort of like last time, these guys over on the left are going to be my source. And these are going to be my destination. So here we go. I have a path from 0 to 1, so I put a 1 there. I have a path from 0 to 2, so I put a 2 there, or a 1 there. Now I have just a single path from 1 to 2, so I put a 1 there. And I put, let's see, I have a single path from 2 to 0, so I put a 1 there. Now, remember, like we said last time, we have no loop backs like this little penciled in guy. Loop back, we don't have him. He's bad. So I'm going to erase him. So we have, because we don't have any loop backs, we always are going to have zeros across the diagonal for the adjacency matrix. Remember, the adjacency matrix shows direct connections. So we're going to have zeros in the rest of these positions. So here we go. I am going to call this ADJ1 for the purposes of this discussion, and I'm going to show it like this. I'm going to show it in a mathematical form now. 0, 1, 1, 0, 0, 1, and 1, 0, 0. Like that. This right here is this right here. It's just that I put it in a matrix. Now, what my trick of the day is going to be is I'm going to multiply, actually I'm going to multiply ADJ1 times itself, and I'm going to generate ADJ2. What ADJ2 is going to show is paths of length 2. For example, 0 to 2 is a path of length 2 if I take 0 to 1 to 2. It's a direct path if I take this path, but there exists this path that's too long here. Now 0 to 0 is also a path of length 2, 0 to 2 to 0. When I multiply ADJ1 times itself, we're going to see those paths. And since we have 0 to 2 to 0, we're going to end up with a 1 in the diagonal, which we haven't seen before. So let's go. So pardon my big clunky hands. 0, 1, 1, 0, 0, 1, 1, 0, 0. So there's ADJ1, ADJ1. Multiply it times itself. Now look, some of you guys haven't had any matrix algebra. The description of how to do it is in our notes. You can watch me do it here. I'm not going to take lots of time to explain it, except for what I'm going to say is to get this number right here, I'm going to multiply this row times this column. How do I multiply a row times a column? I do it each number times each number. For example, I go 0 times 0, which is 0, and then I add 1 times 0, which is 0, and 1 times 1, which is 1. So that was, I'm going to write it right down here, 0 times 0 plus 1 times 0, 1 times 0 plus 1 times 1. Like that. That equals 1, and so 1 will go there. To get this number right here, I multiply this row times this column. So that's 0 times 1 plus 1 times 0 plus 1 times 0, which is 0. Now I'm going to do the same thing. To get this number, I go this row times this column. Hope I'm doing this right. 0 times 1 plus 1 times 1 plus 1 times 0 gives me a 1. Now to get this middle row, I switch row over here and I multiply times each column again. So look, 0 times 0 plus 0 times 0 plus 1 times 1 gives me a 1 there. Then 0 times 1 is a 0 plus 0 times 0 plus 1 times 0 gives me a 0. And now let's see, we have, to get this last number, it's going to be this row times this column. Everywhere this is 0. We can tell. This 0 goes with that one, this 0 goes with that one, and this 1 goes with this 0. Okay. Now to get this last row, take this row and I multiply it times each of my columns. And let's see. You can just kind of guess by looking at where the zeros and ones line up. 1 times 0, and we got zeros, so we get a 0 there. 1 times 1 and zeros gives us a 1 there. And then we only have 1 1 here. So we get 1 times 1 plus 0 times 1 plus 0 times 0 gives me a 1. Make sense? Okay, we're done. So this is ADJ2. And looks like we did it right. What does this thing mean? Let's copy it down. Well, let's just take a look at our graph. So right here, let's do it like this. Whoop. 1 0 1 1 0 0 0 1 1. Let's look at these guys. These will be our source and these will be our jest. I'm going to kind of write it like before. This is 0 1 2. This is 0 1 2. Okay, I'm putting these numbers in here because these are our vertices. So to go from source as 0 to destination as 0, my adjacency matrix here, ADJ2, shows that I have one path that's of length 2. And there it is, 0 to 0. I go 0 to 2, 2 to 0. Now, to get to 0 to 1 with a path of length 2, I can't do it. Look, I have a path of length 1, but I can't do it in 2. That path doesn't exist. 0 to 2, path of length 2, it's there. 0 to 1, 1 to 2. Let's check 1 to 0, path of length 2. It says we have it. Do we have it is the question. 1 to 2, 2 to 0. It's there. How about 1 to 1, path of length 2? No. Look. 1 to 2, 2 to 0, 0 to 1. That is a path of length 3. And we could find that if we multiplied ADJ2 times ADJ1 again. I'm going to leave that for you as an exercise. You can check the rest of these, but you will see that it is there. Well, you can see that this is correct. You might ask yourself how this is working. And it is more than a mathematical trick. I think I can show you. Let's just look at, we're going to just look at this first one right here. And the only way you can really figure this out is by asking yourself, how did this 1 show up? And here's what we'll do. This 1 is here because of the following. We multiplied 0 times, we multiplied this row times this column, and we got this 1. And so that was 0 times 1 plus 1 times 1 plus 1 times 0. 1 times 0. It was this piece that gave us that 1. And so what was that? That was where, here's my source, 0, and here's my destination, and then that overlapped with this right here, 1 and 0. So here I got this 1, that represents the path 0 to 1, and it overlapped with the path 1 to 0. That's where the 1 came from. So this is more than a mathematical trick. What it is pieces of the joining paths overlap, and that's how we get a path of 2. That's it for right now.